Alright, in this video we're going to be doing not Unit 5 but Unit 6 in class worksheet, and let's get started with drawing organic structures. So here in number 1, and actually all of these have a little bit different representation of a condensed structure than what we've seen in class. This one is parentheses instead of the line indicating the branch point. Same idea, this is the branch point coming off of this carbon, and I'll show you that. I'm only going to draw the line bond for number 1, just because it's rather redundant to do that. Maybe I'll do number 3 as well, since that's an alkene, but I will just do the skeletal for 2 and 4. If you want to see the line bond for those, you can check it out on the key, which is posted in Moodle. Alright, so let's get started with the line bond for this one. I'm going to go ahead and count up the number of carbons in my parent chain. I've got 1, 2, 3, 4, 5, 6. 6 carbons in the parent chain. Again, this is a branch point, so I'm not going to count those in the parent chain. So I will draw those 6 carbons out, put bonds between them, and there we have it. And then I see here that at 1, 2, 3 carbons in, I have a branch point. And there's a CH2, CH3 there, so I'm going to go ahead and put 2 carbons there. And now all I do is fill in the rest of the bonds with hydrogen. Remember that each carbon wants 4 bonds. So I'm just going to go through and make sure that I fill in each each carbon with 4 bonds. And it gets a little tight with some of these, the way that I've drawn them, but there we have it. Each carbon has 4 bonds. For the skeletal, I'm going to do the same thing. Draw my 6 carbon parent chain. 1, 2, 3, 4, 5, 6. And then on the third carbon, 1, 2, third carbon, I'm going to put an ethyl group, like so. Okay? And I could have drawn it a little bit differently. 1, 2, 3, 4, 5, 6. And then my ethyl group going up. Same thing. Now I need to name this. So since there's only one substituent here, I'm going to go ahead and circle my parent chain. And since that's 6 carbons, it's hexane. And then there's one substituent here. This substituent is an ethyl group. And it is closer to the left side than the right side. If I count from the left, it's 1, 2, third carbon away. 1, 2, 3. If I count from the right, I'm not going to write this out, but it's 1, 2, 3, 4 carbons away. So I'm going to count from left to right and call this 3-ethyl. And that's all that's needed for the naming. This is the substituent, this is the parent chain. Alright, so number 2, again, I'm just going to draw the skeletal structure for this one. Here I see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons in my parent chain. One, 2, 3, 4, 5, 6, 7, 8, 9. And then if I'm just going left to right, 1, 2, 3, the third carbon over has a methyl group. The next one, the fourth one, has a methyl group. And then I go 1, 2, 3 carbons away from this one, 1, 2, 3, and draw an ethyl. And then I have my final 2 carbons in the parent chain, 1, 2. Okay, so that's how you go from the condensed here to the skeletal. Now I'm going to name this, circle my parent chain. Okay, and then identify all of my substituents. And now I need to figure out which side of the molecule has more substituents. And it looks like from first glance the left side does. But I'm going to actually do it both ways. 1, 2, 3. This is a 3-methyl group. And then this is a 4-methyl. So I'll number it like so. In a different color, I'm going to number it starting from the right, just to make it easier to see. So this here's a 7-ethyl in the red. Now I'm going to go back and label these with the blue. This is a 3-ethyl, not methyl. 2 carbons. This is a 6-methyl, and this one is a 7-methyl. If I add up the numbers in the red, it's 3 plus 4, 7, plus 7 is 14. If I add up the numbers in the blue, it's 9, 6 plus 3, plus 7, that's 16. So I'm going to go with the red. So these are my properly labeled substituents. And then the parent chain is nonane. There are 9 carbons, so that's nonane. All right, number 3. This is an alkene. So I'm going to start by drawing the line bond. I have 1, 2, 3, 4, 5, 6 carbons in the parent chain. But the first 2 have a double bond between them. So I need to draw a double bond. The rest have single bonds. And then I'm just going to fill in. As I see, there's 2 hydrogens here. There's 1 hydrogen here. And then this carbon has 4 bonds, 1, 2, 3, 4. So we're good. The next carbon over has a methyl group. So I need to fill in that methyl group. And then another hydrogen to make 4 bonds. And then fill in the rest such that each carbon has 4 with either carbons or hydrogens. So that's the line bond. And now for the skeletal. Start with a double bond here. So I've got 1, 2, 3, 4, 5, 6. And then on that 1, 2, 3rd carbon over, 1, 2, 3rd, got a methyl group. Now, when we're naming alkenes, we need to name the alkenes according to where the alkene is closest to. So since the alkene is closest to the left side, we're going to start numbering from the left side. And our parent chain here is 1-hexene. So our double bond begins with the first carbon. And then we have 1 substituent here, which is a 3-methyl. And that's it for the naming. On number 4, I'm just going to draw the skeletal. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. And then if I count from left to right, 1, 2, 3rd carbon over has a double bond. 1, 2, 3rd, beginning with the 3rd. So it's in between the 3rd and the 4th carbon here. Also on that 4th carbon is a methyl group. Okay, so now where do I start numbering from? Well, if I count from left to right, the double bond begins at the 3rd carbon. If I count from right to left, 1, 2, 3, the double bond begins at the 4th carbon. So I'm going to count from left to right. Always remembering that this the counting for alkenes is going to occur in order so that the alkene is lowest numbered, is the 3-heptene rather than 4-heptene in this case. And then our substituent here is a 4-methyl group. All right, next page. Okay, so this is kind of going in the reverse. We have skeletal structures and need to draw condensed structures for the following and name them. All right, so first thing I need to do is figure out the parent chain. So I'm going to start here. 1, 2, 3, 4, 5, 6, 7 carbons if I go up. How about this way? 1, 2, 3, 4, 5, 6 carbons if I stay low. So I'm going to go ahead and say that this one is the parent chain. And so I'm just going to draw starting from left to right in the condensed form. So first one is a CH3, the next one is a CH because I have a methyl group here. So CH3, this is CH, and we could do this one of two ways. We could either do it in parentheses like we saw on the previous page, or I could just put the CH3 up here. So I'm going to stick with this method here, a little bit different than the page before, but just to give a little variation and show you that they are the same thing, just different ways of denoting the information. Next one is a CH, and I know it's a CH because this carbon has 3 bonds to other carbons, so it must only have 1 bond to hydrogen. And then I'm going to put this CH3 down here. Moving on to the next carbon, this one is also a CH, except this one has an ethyl group coming off of it. Okay, CH2, CH3, that's what these two are. And then the next 3 have no substituents, so it's just CH2, CH2, CH3. Okay, so there's the condensed form of this. Now I need to name it. Parent chain we said was 7 carbons, so parent is heptane. And then it's pretty obvious that there are more substituents on the left side of this molecule. There's one here, there's one here, and there's another one here. We would say that the middle of the molecule is about right here. So the left side is more heavily weighted with substituents. So I'm going to go ahead and number from the left. And I see here that I have a 2-methyl and then a 3-methyl. And this one is going to be 4-ethyl. And there we have it. All right. So number 6, similar type structures to the last one. Parent chain in this one is a little bit more obvious, I think. Just goes like that. And then we're going to start from left to right. CH3, CH2, CH. And this has a methyl group coming off of it. Doesn't matter whether you draw these up or down. I just kind of done it that way. The next one is a CH. That's this one here. And then the rest of these have no substituents. So it's just CH2, 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 CH3. So 4 CH2s followed by CH3. Okay, so that's the condensed form. And then we need to count the carbons for the parent. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nonane. And then again, this one's a little bit more obvious. We're going to start counting from the left because you can see there's more substituents on the left side. The middle of the molecule is about right here. So we're going to count from the left. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is a 3-methyl, and this is a 4-ethyl. All right, number 7. Parent chain is here. One, 2, 3, 4, 5, 6, 7, 8. So that's octane. And then I'm just going to start drawing from the condensed here. CH3, CH2. Third carbon is a CH with a methyl group attached. Then another CH with a methyl group attached. Then this carbon is the next one is an alkene. Now we aren't going to talk about this just yet in class, but later in the class we will discuss the difference between these kind of double bonds and the double bonds we saw on the other page. You can see this one looks a little bit different. The other type of double bond is like this, where it kind of comes down and then up, whereas this one is sort of up, makes almost like a mesa or plateau here, and then comes down. And there's a difference between those, but we'll cover that later in the class. Nevertheless, I'm going to draw the double bond the way it appears here. So if we were to kind of fill in H's up here, this is what we'd see. We'd see like 2 little horns here for the H's, and then the remainder of the molecule comes down like so. Okay. Now we could have drawn this. We could have drawn this like this, and this would have been totally fine. CH, CH. Okay, I didn't have to draw the little horns there. Just kind of doing that to emphasize the fact that this is a special kind of double bond, different from this one. All right, so let's name this. Parent is not octane. The parent is octene, but where is the address here? Okay, remember that we always name alkenes according to where the alkene is closest to. In this case, that's definitely the right side of the molecule. So I'm going to number from the right to left, even though more of my substituents are on the left. So I'm actually going to get rid of all that. This is 3-octene. 3-octene. Begins at the third carbon. Substituents are 5-methyl and 6-methyl. All right, on to the last one. Parent chain is going to be 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7, so it doesn't matter. So I'm going to just keep it simple and have the parent chain be right there at the bottom like that. No alkenes, so this is heptene. I'm going to draw out the condensed. Start with a CH3 on the left. Next is a CH with a methyl substituent. Next one over is a CH with an ethyl substituent. And the next one is a CH with a methyl, and then we're here. So 2 CH2s and a CH3. Okay? And then we need to name our substituents. Well, first number 1, 2, 3, 4, 5, 6, 7. This is 2-methyl, 3-ethyl, and 4-methyl. All right. So I'm gonna cut off the video here and do part 2 with the remaining pages.